Hey, welcome everyone to another episode of Chips and Salsa. I'm Jerry.
I'm Chrome. And Jerry, today we have a great show lined up with folks from both Intel and our friends over at Google. They're joining us today to talk about how we collaborated over a 9-month period to conduct a security review on Intel Trust Domain Extensions, also known as TDX. And this is a new technology that's available starting with the release of fourth generation Intel Xeon scalable processors.
Yeah, Crow. In our 2022 product security report, we talk about many of the ways Intel invests in product security assurance,
Mhm.
and the collaboration here between Intel and Google to conduct this security review of TDX. It is just another way that we seek to provide higher levels of that security assurance.
Yeah, for sure. And TDX introduces a whole new set of architectural elements to help deploy hardware isolated virtual machines called trust domains. And given the importance of technology like TDX to confidential computing, it was great to have the security research expertise of our partners over at the Google Cloud team and Google Project Zero. And they conducted this review in addition to all of our internal research efforts to help get that TDX system hardened.
Yeah. So let's cut to the interview and find out about the scope and results of this collaboration.
Let's.
Hey, welcome everyone to the show. Glad to have you all here. Let's start with introducing yourselves and what your roles are, and we'll start with the folks from Google.
Well, hi, thank you for having us. So my name is Andres Lagarcavilla. I'm a principal engineer at Google Platforms, and I'm responsible for platform security for all our data center products.
Hello, everyone. Hello, everyone. Thanks for having us. My name is Kfir Cohen. I'm a tech lead on the Google Cloud Confidential Computing team. My team brings confidential and trusted computing technologies to Google Cloud.
Excellent. Andres and Fear, it's good to meet you on this call as well. I'm Dinesh Manoharan. I lead Intel's offensive security research organization with a global team of super talented folks across the system security research world. The mission of our team is to make sure that Intel product innovations are delivered to the market with a very high level of security that customers can trust and their businesses and lives with. Happy to be here to sit down and have this conversation about our collaboration.
And I'm Truc Nguyen. I run a team of researchers in the products assurance and security team, division at Intel. And my focus is in security technologies for the server market segment, right? And for this conversation, I led the Intel side for the TDX secure research joint research with Google team.
Excellent. It is wonderful to meet you, gentlemen. This is going to be a really exciting conversation today. So, the reason we're here is that Google and Intel worked together on a security review of Intel Xeon processors, and specifically the Intel Trust Domain Extensions, or TDX. And before we talk about the results of the review, could you maybe tell us why a feature like TDX is important for the Google Cloud platform?
Great question. First, I would like to give a quick shout out to all the engineers who worked on or participated in this security review. So we have Erdem Aktash and Josh Eads from Cloud Security, and James Forshaw and Felix Wilhelm from Google Project Zero. First, let's talk a bit about confidential computing, and then we'll talk about TDX unique features. So confidential computing and why we're excited about this domain is because it helps customers solve hard problems. And the hard problems are how to establish trust in a remote system and how to maintain that level of trust in that remote system. With confidential computing, you have this feature called remote attestation, and remote attestation helps users reason about their trusted computing base, or TCB. With remote attestations, users can build data access policies that are centered around code identities, right? So you can have a policy that says, hey, only this binary has access to my encrypted database. And this is useful because it opens new use cases like secure data processing and multi-party compute. You're probably familiar with the two A's in the security engineer's toolbox, authentication and authorization. The third A is attestation, which is quite powerful. In addition to remote attestation, confidential computing also offers runtime security guarantees, right? Confidentiality and integrity. It protects a workload from its hosting environment, the host hypervisor, the virtualization stack, co-located tenants, and also peripheral I/O devices. With technologies like memory encryption and memory integrity controls, they keep the workload safe from inspection and tampering. Or another perspective, another way to look at the problem is that with confidential computing, we give the control back to the owner, right? So the guest workload has full control over the data that comes into the confidential environment and how it leaves the confidential environment.
Yeah, I think so. Fear summarizes very well, very precisely what we're after. Let me emphasize a couple points, right? So every 10, 20 years, we turn the knob on isolation and we hit another steep upside. It was virtual machines in the past. The way we look at confidential computing is the same. It's the next sort of gen of isolation. And it's also kind of completes the picture, right? We've evolved as an industry. We have data protection at rest. So, non-volatile storage, if people steal it in general, they're not going to be able to get at anything. Data protection in transit. So, you can trust the internet and those things, and to a degree, and data protection in use. So this is about the actual processing that is happening inside cloud computing, which at the end of the day, a lot of people use it as infrastructure as a service. So they want to rent that electricity and that silicon, et cetera, but they want the processing of the data to be protected while in there. So for the mechanisms, I don't want to sort of like regurgitate. For the mechanisms that Fear mentioned, this is how we get to that third pillar of data protection. For us, the attestation story is super important because it moves our users ever closer to a very complete understanding of what is processing their data. With technologies like TDX, the TCV is dramatically shrunk, and now we all of us, the industry as a whole, are looking at the very real possibility of end-to-end attestations of verifiably built open source trusted computing base. So as a user, if you want to be empowered, you can be empowered. You can actually verify and you can understand all the code that is handling your data. And the last point that I think is super useful, super important is usability, right? So Intel is a trailblazer here with SGX. SGX came out earlier than anything else. What TDX allows is it allows people to lift and shift their VM workload and drop it into a confidential compute environment, removing some of the steep learning curve of SGX. So it's definitely a major usability gain, and that's a big important reason of our excitement here.
I wanted to just add to what Fear and Andres said. We are also, from an Intel standpoint, really excited about this partnership for a few reasons, right? So confidential computing, as was mentioned, is a next major leap in the cloud service market where customers can trust their most sensitive crown jewels to be brought in for secure computation, secure storage, and really enabling some creative usage models, including a range of AI applications and such. Right, so TDX is certainly going to be a very key technology that brings such usage models alive. The end-to-end attestation is a key aspect of it as well. And for a lot of these reasons and more, we are excited that we're able to work with Google Cloud team, and really bring such a technology to the market. I think the future of cloud computing is really getting a huge start with this sort of launch.
Yeah, thanks for that. So let's kind of jump into it and start with, what were the goals and scope of your security review of TDX?
So we had two primary goals. The first primary goal, was to sort of fill the role of an independent auditor, right, that can examine and verify the TDX system, verify that it meets a high security bar, and also help fix any latent bugs in the system before it becomes operational. By working closely with Intel and by making the report publicly available, we hope to make this foundational confidential computing technology safe and safer for everyone. So not just Google Cloud users, but really anyone who wishes to gain confidence in TDX. The second goal is we also need to keep in mind the TDX module is a highly privileged component in the system, and so we need to review it for security and reliability and make sure it cannot be abused by a malicious actor to compromise the host system or to negatively impact neighboring guests. So those were the two main goals. In terms of scope, we reviewed both software components and hardware components of TDX. The two main software components in TDX are the SIM loaders and the TDX module. The SIM loaders, they load the TDX module to this dedicated memory range called SIM range. And the TDX module is a sanitized hypervisor. It mediates access to TDs, and it also manages the nested page tables. I would also like to tell you a bit about the process. Oh, sorry. The next bit is the hardware component. The main hardware component for TDX is MKTME. That's the multi-key total memory encryption with integrity, which is a memory controller feature that protects memory for confidentiality and integrity. Other hardware components, such as the SGX-based attestation or the IMMU key filtering, were out of scope in this report. I want to tell you a bit about the how, about the process, about the security review process. With Intel's help, we formalized the security invariants that the TDX module tries to maintain. Then we reviewed the code, we manually reviewed it for security and correctness, and we drafted a threat model, and we analyzed various guest to host or end host to guest attack vectors. You see in figure 3. It shows you the quite wide attack surface, right? Because the host hypervisor is quite capable of impacting or influencing TDs and the TDX module. So we drafted this threat model and we analyzed all the different attack vectors. We also used some very interesting tools in our research. We used static analysis tools like Pharmacy and Wegley, all linked in the report, to search for vulnerable code patterns. And in addition, we also used Civics, which is a CPU simulator, to run some dynamic tests against the system.
Awesome. So from the Intel side, what were some of the goals and scope of this security review?
Thank you, Fear. I will get started on the goals and scope from an Intel standpoint, and Truck, if you could also supplement my comments, that would be great. So from a goal standpoint, we really had 3 goals. Right. The first one, we wanted to demonstrate to our customer, Google, in the cloud service standpoint, the rigor of security assurance that Intel has put in building this technology, right? All of the SDL work, all of the red teaming work, all of the offensive research work that has gone in being able to get this technology to life. We wanted to be able to demonstrate that and preview that with Google. I think that was one goal. The second goal is we wanted to proactively work together. As Pierre mentioned, sort of align our threat model thinking about this technology and how it lands in a customer use case. Do we have our threat models aligned? Are there any things that we see as in scope, they're seeing out of scope, and vice versa? So having this sort of a converged view of the threat model that supports these confidential computing usage models and such, that was a great exercise to be able to collaborate on. That was one of the goals. The third part is we really wanted to bring our talented researchers from both teams to work together on, not only just looking at the threat model and refining it together, but also going through the exercise of deeper dives into the code reviews, the vulnerability analysis, the tools and the dialogues that we had, lots of questions generated that drove more internal efforts on both sides to be able to find answers for those questions. All of these things were part of the goals, was for us to be able to get a thorough look at the technology as it lands in the Google Cloud platform, so that we can walk away with the confidence that we can generate for ourselves about this, and then we can also be able to share some of these details through white papers and other such things to our customers in due course. So those were the goals. The scope was exactly what Fear said, so I don't want to repeat that much. It's really going through the architecture and the implementation of the key modules like TDX module and SIEM loader and such. Truck, do you want to add anything to that?
Yeah, I think in addition to what Fear and Dinesh said, I think the only thing that I want to add is from a scope perspective, beside the key module, TDX module, and the SIEM loader, both persistent and non-persistent module that we really focused on, there were multiple other ingredient or component in the SOC as part of the TDX flow evaluation that we looked at, right? So, things like what happened in the core when something happened, memory controllers, access control, MSR review, even side channel implications. So there's other SOC type of ingredient that were also part of the review from both architecture and design. Although we did not have share the say RTL code or hardware, but a lot of the enumeration of potential attack vectors went through that. Okay.
I think it's very fascinating to get a glimpse into kind of the rigor of the sausage being made, so to speak, in this partnership. But what I'm really excited about is let's hear about the results. You put a lot of kind of very disciplined work into your analysis. What did you find? What were the results?
I'd love to start with this, but first I want to say that TDX was a very tough target to crack. The system is well designed, has solid implementation, and really hats off to all the teams who worked on design, testing, and validation. With that, I will mention that we did find a couple of critical vulnerabilities. I want to maybe highlight here, just add some flavor and color to the discussion. So one of them was in the ACM TDX loader. We found a bug in the exit path, in the exit flow, where we could trigger an exception with an attacker-controlled IDT, interrupt the descriptor pointer, which led to RIP control and remote code execution. So if you look at the diagram, figure 9 in the report, you'll see this. So this is running on CIMIX, the CPU simulator, and you can see that we managed to trigger and gain RIP control inside the highly privileged ACM, the non-persistent SIM loader. Very diligent in fixing this promptly. The other bug was related to how ECC settings are maintained post-BIOS. We found a way to disable ECC and thereby enable raw hammer attacks on server-grade DIMMs, which are a potential threat to confidential computing technologies.
And then I like to add, in the kind of from the summary of the result overall, I think the team managed to discover and confirm 9 security vulnerabilities, and I think there was 4 or 5 what I call defense in depth. And from a product launch perspective, we were able to address and mitigate all of them by the launch of our 4th generation Xeon processor.
Yeah, so I think it's important to emphasize that last point. The joint work yielded around 9-10 vulnerabilities. Don't fret at the site or hearing the words critical vulnerability. These things happen all the time. The good news is we found them. This team found them, right? And they've all addressed, as well as 4 or 5 defense in depth. These are very complicated, very nuanced. Hijacking the interrupt return vector. People have done it in the past, but it's pretty impressive kind of work. And so I think overall this is a great success. This is what we were after. Make this thing harder, make this thing better, make this thing harder to penetrate and break for the benefit of all of our users.
Awesome.
That is pretty fantastic results, and appreciate the comments about the validation work that happened ahead of your security review. So this kind of collaboration seems very valuable. What would you all say were the learnings that you took away from it?
I think the top learning is that we can work together constructively, transparently towards a common goal, right? And I think something certainly Google would like, the audience and Intel and everybody else in the industry to take home. This is for the benefit of all of our users, right? One of Google's security team mantras since the beginning of the company is make the internet a safer place. Now you look at this, cloud computing is part of the internet. So at the end of the day, these findings and these improvements and this hardware of TDX, they will be leveraged by Google Cloud users, they will be leveraged by users of other clouds and other on-prem services, everybody who's lighting up TDX. This is fine. This is what we were after, right? This is what Google has been doing with the Project Zero body of work and other things for a long time. The awesome new ingredient, the critical transformative piece, is we're now doing it with another, giant of the industry, a very large company, Intel. And I think that's one of the new tweaks on this one that is really satisfying. Really, it's an accomplishment.
Yeah, if I could just add one quickly, Truck, before I turn it over to you, right? So I completely agree with what Andres said. We look at it as, there's this aspirational goal in the industry about certain problems and security threats and all. We need to be working collaboratively across the industry to be able to benefit the user and enterprise and things like that. Um, while we talk about it a lot, finding real good examples of where that is truly happening and working collaboratively, not just once, but looking to be able to repeat this going forward, in this industry. I'm very proud to actually being involved in this sort of engagement, and the results speak for themselves. We are really increasing the confidence for ourselves as we launch this technology, and our customers are going to benefit from it. And it's not just between Intel and Google, right? All the entire cloud industry is going to be the beneficiary of it. So I think that's a very key learning. So much that it shows us that we can do this. We can do this again and again consistently.
Yeah. And I think at the more at the secure researcher perspective, we also learn quite a bit, right? We understand and learn about Google, what they care about, their threat model, their usages, the application of tool. There were several tool, crypto tool, static analysis tool that will apply to evaluate our software and our solution. So that's one aspect of it. The other one, based on a couple of critical findings in the ECCs and ACM that Phil mentioned before, we look at what were found, and we actually internally look at adjacent areas for ongoing product development, future product, and also already launched product. And as part of that, we also found an issue with SGX in Ice Lake, right? And Intel released a security advisory with a CVE. I think it was CVE 33196 that's related to a default permission on memory controller for SGX, right? And we want to take this opportunity to also thanks the team, the Google team, for helping us kind of make us think about some other area and again, not directly to TDX, but we were able to also improve other products at Intel.
That's awesome. It's really impressive, kind of seeing the expertise gathered here and the kind of collaboration. And as we wrap up, can you reflect upon how this collaborative review helps our customers as they think about adopting confidential computing?
So if I can take that, right? So one of Google's core values is respect for the user, right? Now you look at Google, we have a large palette of products: YouTube, Gmail, ML, and now infrastructure as a service and product as platform as a service. We feel strongly that confidential compute is a fit for all of this, right? That's why we're investing here across everything that we do. Now, when you look at the industry as a whole, one of the less pleasing patterns that we have seen is that there's a lot of security through obscurity in the low level security, strata. And this is important. What's happening here, right? When we look at a technology like confidential compute, it's based on a small, reduced, low-level TCP. We look at this technology, we think we're going to onboard it. It's going to take us, we look at it years in advance, and we start preparing for it, and we start preparing for how is it going to work out for our users. So we start thinking, okay, this is very opaque. We need to work on this. If you look at what Google has been doing in the low-level space, you see contributions that are all open source, right? Boring SSL, OpenTitan, Syscaller and Sysbot, Calyptra, right? So this is where, for us, it comes together, right? Basically, we do this audit, we make this stronger, it comes out, it's open source, it's verifiable. Go to the third way that we alluded earlier in the conversation, right? So you have a verifiable open source trusted compute base that our end users can attest to. So this is really the holy grail in many senses of where we're going and how we feel we're going to make the internet and cloud computing safer for our users. So trust is earned. It's earned through hard work. So we're hoping that this is one step in that direction to earn the trust of all of our users across Google and Intel.
Yeah, I think Andres well said about some of the benefits that customers get to see with this. I mean, as we've talked through this conversation here, confidential computing is a major advancement, right, that addresses a lot of security and privacy concerns among enterprise customers and users. Those that have been hesitant about public cloud, hybrid cloud, and other sorts of usages that would come through it. This is a key enabler to be able to sort of overcome those hesitations as well. So ensuring that such technologies are coming to life, we are proactively working to be able to build the sort of a robust solution. And company boundaries don't matter. We're working together to be able to perfect the technology. I think this is awesome. I hope that the customers are seeing how we are being transparent about it. The open source for verifiability. We're putting out the white papers and the details about this research, including the vulnerabilities and things like that. All of that is for customers to see. They will also be gaining assurance that this proactive work led to mitigations, led to fixing of many of these things, and we were well prepared for the launch of this technology with all of these findings. And we will continue this. I mean, security is never done, so we will continue to do that. So I think the confidence that this generates for our customers is what we're really hopeful of, and we want to be able to continue to demonstrate the security first thinking going forward.
Yeah, that's fantastic. So, okay, so on the Google side, you guys published your research findings, and we'll put a link to that in the show notes and below.
Perfect.
And with that, we thank you all again for joining us today and for talking to us about this unique collaboration
Amazing
around
work.
Intel TDX. Thank you.
Thank you so much.
Wow, what a collaboration. And the results indicate that our own hardening efforts were very extensive.
Yeah, really fantastic results. Good review from the Google folks on, how hardened the technology was when they started the review. They did find some really good bugs.
Yeah.
And for our viewers who want to learn more about Intel TDX, check out the link below. And Krob, that's it for this episode, and we'll see you all next time.
Later.